Okay, hello everyone. We're going to get started, so please have a seat. So welcome to this session on using data to anticipate, predict, and respond to emergencies. My name is Alfonso Zamarro. I am one of the vice chairs at the EENA Tech and Ops Committee. I'm also the CEO and co-founder of Blur. And well, today we're going to talk more about data, artificial intelligence, how all of these technologies that are widely available in different industries can actually help to emergency services to make their daily work easier. So today with me, I have John Thompson, who's a Senior Director, EMEA, Defense, Justice, and Public Safety at Oracle. We have as well Valerij Grašič, sorry for butchering your name, Solution Manager and at Iskratel on behalf of the 5G Safety Project. And we have also Michael O'Donnell, firefighter at the Dublin Fire Brigade in Ireland. So without further ado, we're going to have our first speaker on scene.
Hi, everybody. Thank you for the opportunity to present here to EENA. I've been here a few times before in the past, and I work for Oracle, and it's great to be back, and particularly great to be back in Marseille. Allow me to be a bit provocative. Are we paying enough attention to the data and the information that it presents to public safety agencies, those organisations that we've come here to meet today and who are amongst us? We're here to support public safety agencies, but how well are we really doing with the information that's being produced by very professional, leading-edge organisations like Motorola, like Hexagon, like Mentor and Saab and Oracle, in fact? But there are huge volumes of information. And are we really using that information in the best way we can to support the public safety agencies that we work with? Could we do better? I want to talk to you about something critical. Something I was skeptical about only a year ago. Is it real? And if it's real, why aren't we all working on it? What am I talking about? What's the big deal? I'm talking about the biggest event in human history. According to Stuart Russell, who's the professor of computer science at Berkeley, California, and also the founder of the Human Compatible Center for Artificial Intelligence is the biggest event in human history. That's a big deal. Bigger than heart transplants, bigger than the moon landing, bigger than going to Mars. Do you agree with the professor? For decades, the people here have been involved in producing infrastructure, networks, devices, you name it, all of which are producing more and more and more and more and more data. We're swimming in data. There's a tidal wave of data coming. Sink or swim. Sink or think. Artificial intelligence feeds off data, but what is it? In simple terms, it's taking insights from data, applying knowledge, and using it to take action. And the organisations we're here to support are all about taking action. Have a look at this slide. On the left is some analytical work that we've done using Python, which is a programming language, Python algorithms, to take age, gender, the country you live in, the R number, the border controls, the testing approach, and use all of those to predict COVID mortality, death from COVID, with an accuracy of over 80%. On the right-hand side is analysis of police stop and search from the UK and Wales, England and Wales police forces, which analyse stop and search stats. Now, as you would imagine, there are certain kind of trends about who has been stopped, what they were searched for, what was found. Many of these things probably already known by public safety officers and police. But you'll see at the bottom right of the diagram that I've identified 5 clusters of information that no human being could possibly see. Not even a chief constable, not even somebody with 30 years of experience of working in public safety. So how does this affect critical decisions and who makes them? What is the significance of such information? And how can it be used to allocate resources which could become scarce as we still recover from the impacts of COVID, to devise operational initiatives and future strategies? Let me just say a word or two about data analysis categories. Historical data is data you can use from the past to see a trend, to see if you were right perhaps about a historical trend. Forecasted data is something that you can take historical data, put it into a spreadsheet, make some assumptions or even a calculator, and forecast something that's going to happen. Predictive data is using massive processing power through modern technology and very advanced algorithms developed by data scientists to predict future events with high accuracy. Here's a graph of historical knife crime statistics. What we wanted to know was, did COVID have an impact on knife crime? And you will see a total of all the forces in England and Wales, which show in the pink column that knife crime did in fact fall because of COVID. What is it that decision makers in public safety organisations, in ambulance and in police organisations, would choose to do with that kind of information? Maybe they're doing it now, and certainly when I was the Chief Information Officer at Scotland, responsible for 8 police forces, initiatives like the 5-a-side Midnight Football League were put together by chief superintendents to distract those that might get involved in knife crime into other activities. This next slide answers the question, can we forecast increase in knife crime? And again, you can see, this is using Tableau, another application, you can see that knife crime is forecast to increase. These are 21 and 22 statistics, actually 22 and 23. The very morning after this analysis was done, there was a radio programme on BBC Radio 4 in the UK which talked about concerns about increasing knife crime. The data was there. The data was already telling us. How do we use that data to inform the public safety organisations we work with in order that they can make decisions that help the operational priorities, like reducing knife crime? This chart shows the violent and sexual crime in a city called Coventry in the UK, and shows a chart which no human could predict. These are the actual violent and sexual crimes in that city. But a machine can, and a machine did. And you can see how close the predictive crime stats are to the actual. What would chief officers and their decision makers and strategists do with that kind of information? information that you cannot possibly see if you're a human being. You need machine learning, you need artificial intelligence. What would they do with their people? Where would they put their people, their assets? Where would they invest money? Would they be influenced by this kind of information? Of course they would. But what are we doing to give them that information so they can make this decision? This diagram shows the micro postcodes in Coventry where those predicted statistics show violent and sexual crime to be most likely to happen. And again, if you have that map that shows you in 6 months' time, in 12 months' time, this is going to happen as a police, fire, ambulance decision maker, you will do things differently. How are we giving them this information just now that we're collecting from the kind of command and control capabilities that we see outside from Saab, for example? In addition, for efficiency-hungry chiefs, predictive analytics is relevant to the support functions as well. So why do they want to be efficient? They want to be efficient so all of those resources are targeted at those operational objectives. Ambulance HR directors can predict the resource requirements for their organisation, the future resource requirements. And of course, paying people has a financial aspect. Fire and rescue finance directors can anticipate the spend on salaries, but also on all sorts of other things, and forecast, predict budget requirements, for example. If humans have that information at our hands today, we can do this predictive work. And what of tomorrow? Who's going to make these decisions in the future? Who's going to use this data? Is it in fact going to be human at all? Do you feel reassured by that? Or do you feel like you need to do something about it, to learn more? Or maybe there's time to learn a bit more about artificial intelligence and how that relates to public safety. And this takes me to a thought process of the organisations I've worked with that have disparate systems, like Scottish Police, 8 Forces, like the Police Service of Northern Ireland, British Gas, Airbus, Ericsson. We've still got to deal with the disjointed infrastructures, the multiple applications and contracts, the protocol integration, the IoT standardization, the social media policies, the mobile data and digitization, command and control modernization. When do we deal with artificial intelligence and machine learning? When do we define how AI will be used in public safety? And how long do you think we've got before AI is integral to what we're doing, whether you like it or not, and handles at least parts of the processes and systems of public safety? 15 years? 8 years? Elon Musk says 5 years. 5 years, the time it takes to do a degree. And I quote, "We have 5 years, and I think digital superintelligence will happen in my lifetime, 100%. That's what Elon Musk says. Back to Professor Russell. At some stage, we should expect the machines to take control. Let me repeat that. At some stage, we should expect the machines to take control. That means control of command and control and dispatch, control of procurement of appliances, and appliance of budgets. And this will be built on the discussions and the decisions that we make today, or without those discussions, regardless. It's going to happen anyway. In fact, it's happening all around us. It's evolving all around us. Do you feel like you need to do something? There is an exploding array of data sources. Please find an ambulance organisations in Marseille, in France, in Europe, are already saturated with data. They tell me we don't know how to get to the information that we need. They're too busy dealing with what's out there. How do we help them to deal with that? We may already be out of our depth in data, and there's a tidal wave coming. We're in a sea of data. But are we actually good at capturing that data from IoT signals from the ground, from radio and mobile communications from the field, from satellite, from the sky, without errors, duplications, omissions, rework, representation, reinterpretation, hesitation? No one likes delay, but hesitation could be fatal in the world of the people that we're here to serve. Analysis and prediction is a very demanding, consuming profession. The data scientists, that's what they do all week. They can't understand the operational objectives of public safety organisations in the way that you do. Who will shape and interpret this data for the chief decision makers? By focusing on the operational outcomes of those organisations. We cannot wait for this to evolve around us. Data and information is only useful when used to address operational objectives, like reducing domestic violence, like stopping knife crime, like reducing the permanent effects of a heart attack, like faster response. We need to be clear on what problems we are trying to solve. No computer, no machine can do that. Please consider this in the rest of the conference. I know it's somewhat provocative what I'm saying, but if AI is the most important thing in human history, why aren't we working together to give public safety officers and chiefs the information initiative? What can we do? What can you do? Artificial intelligence, yes, it's real. Let's consider AI in emergency services while it's still emerging. Thank you.
Thank you, Jan. Any questions from the audience? Here we have someone on the first row. Here's the microphone coming.
My experience was not actually with artificial intelligence as it is at the moment, but was with knowledge-based systems. And was with the application of knowledge-based system to critical systems, safety-critical systems. And one of the biggest problems at that time was the validation of those systems. And I think in this domain it should be almost the same. If I want to trust the information, I need to know how the artificial intelligence has decided something, and this way of how to decide something need to be validated. So is there any progress? Because at that time, that was the real problem of using artificial intelligence. The credibility and the possibility to validate the mechanism and decision were taken.
It's a great, is this working? It's a great question, and it's very, very relevant, and it will continue to be relevant. So we are better at it, but we're not good enough at it. Historically, it has been a problem. We all know that, you know, when you're capturing information into a command and control system in the heat of the moment, remembering the exact etiquette of how you're supposed to lay out dates and things like that can be of secondary importance to actually capturing the information and resolving the situation there and then. There are, data science is a really involved profession. I've been fortunate enough to have spent some time in it recently. I'm not a data scientist, but I can see why it's all consuming, because preparing that data is probably the most time-consuming part of dealing with machine learning. Getting the data ready requires or offers algorithms and techniques to recognize an ampersand and an and or a misspelling and do complex algorithms just to prepare and clean the data. So that's quite a specialist area in itself. And if you want a good outcome in terms of those maps, you need to have invested a lot of time to get that data to a position where not only does the visual mean something, but actually those people that rely on it have the confidence in the data. In some areas, like stats are collected from for the Home Office for stop and search, that's where we got them from for UK, then it's more reliable. But they've had to prepare it, the police forces, to put it up on the Home Office, to send it to the Home Office. In other areas, the data is really quite poor, and it's a problem, and there are multiple applications and multiple entries and, applications that keep the same information on two separate systems but are slightly different. So there's work to be done there, and this is my point, that unless we are driving that work to get that consolidated, because multiple applications are a fact of life, then something organic's going to happen, and people like you will always be saying, but can I trust this data, and can I make decisions based on it? So it's a good question, and yes, things are healthier, but they need work.
Perfect. Thank you very much. So we are a bit short on time for the questions, so we're going to move to the next presentation from Valerij on how to forecast the number of incoming emergency calls based on open data from Internet of Things. So floor is yours.
Oh, thanks. Hello to everybody. So today's presentation will be about increasing resilience and resistance of the smart cities, because public safety and 112 numbers are part of a big ecosystem that's smart cities. And that was the first main focus of that research that was made. And it was focused on the forecasting of 112 emergency calls. That means the prediction for the future that is connected with the time data or time in the space. And the third main point of that work was to use open data. So that was, as I have said, it was a research within 5G safety project. It was based on the simulation, and in the future it can be integrated in the product. So key objectives of this was to use it for the operation center, for the different professionals, also for the citizens. For example, if we know the information of the incoming calls, we can staff be better prepared, and we can prevent some heart attacks. And this is, if we see some events that are going on, for example, like in floods in Ljubljana in 2014, then we can prepare for the future what will happen, and we would like to. The main of that presentation was to prepare the general purpose model for such forecasting, and which can be used in the future as a digital twin ready for the next NG112 product. So what is the problem now, or where we are now and where we would like to go? So the first point of the future of all the climate changes, or all of the cities, or all of the research of the last 20 years in the area of the smart cities talks about one thing: resilience, resistance, and how to be cities prepared for the future. And if we want to go to such a future, we need to be more dynamic. We need to support more dynamic handling of all the things. So if we take from that point of view, we see that the existing systems are maybe a little bit non-flexible, too static. We heard about technology is not prepared. We need to do it manually. We lack of support, and we have some rigidity of the system. And our aim to go into such a smart city, more resilient handling, is to first see where it's so much number of the incoming calls to be like an alarm, and then to these numbers or these incoming calls to put into different size classes, and the main point to conversion of future calls. So what will happen tomorrow, 2 days before or ahead, or 1 week ahead, or in 3 hours ahead, to put these calls into the predefined classes. Just one thing more to mention, in Slovenia we have, this is valid for Slovenia, we have 2 million inhabitants, with the capital of Ljubljana with 35,000 people, and our system PSAP consists of first and second level, and some calls goes to the police goes also to this PSAP, but some goes directly to 113. So that's a little bit different from the other countries. So we do this research based on the typical CRISP DM methodology. That means what is the business understanding, how to use that product or the solution, to understand the data, which data use, what is the structure of data, how to prepare the data, organize data for modeling, and then to handle modeling. We know in artificial intelligence we have a lot of models that can be better, different for different purposes, and then to evaluate all these models and results and put some conclusions. So for the business understanding, if we see the picture on the right side, we see that there's the number of incoming calls, the real incoming calls in November 2014. In that year, it was a lot of natural disasters in Slovenia from February up to end of the year. In November that year, it was flooding in Ljubljana. We see a small number at the beginning, and then peak, and then flooding, very long-lasting flooding. And the number of calls fluctuated. And this is typically for Slovenia and also for other countries. It depends on the day, on the hour, on the year, even on years. There's no. But we would like to prepare to make one framework that would be general purpose forecasting model, which can be scalable. We would like, the idea was to use it for Ljubljana, for another cities, for the regions, for the maybe expand to firefighters, to police, maybe to ambulance. So not to be just like time series, one very special model, but very robust. And what data to use, which open data and why. So that was, we have checked and we see where was the main damage. It was due flooding, due water, and due weather situations. So that was the reason why to use this data. And it was also that we would like to be prepared for the future, for the climate change, for all the changes, flooding. So we would like to have a model that would be more dynamic, could be more dynamic handling, with which the staff could prepare the control rooms and other staff. And what it was the idea to not use just for PSAP alone, but also for the control rooms, like in the smart cities. In the future, that's PSAP would be like a kind of the smart city ecosystem, where the citizens will be that to whom we serve. And also such a PSAP system with forecasting model could become and would become the digital twin of 112 call number within the smart city. And we would like to see that we don't need the exact number of the call numbers, but we would like just to know the call size. So we would put in just the information, general information, what kind of the calls will be, what call size would be. And which data we have used. For setting the model, we need the number of incoming calls. We see that there were numbers available from 2013 years on. We see also that these numbers, if we have checked that there's fluctuation or what was different for the second period. We use it for the second period also because just to check the models. We see that the average number per days, because we started with the day calls per day, average number was different for the first and the second period. For the other open data, we use data from the Koledar, data from the weather station, 10 weather stations within all the country, and with 16 data per station, and with 16 river flow station, only the river flows, and traffic incidence data. And okay, now we have data. What to do now with data? The first step was to prepare the data sets. There were 2 data sets just to handle, to see what to do with the data. And one was for the Slovenia with 176 attributes, and the other one was only a subset, because in machine learning we have also the small models, the models with a smaller number of the attributes. Just for the simplified, it can be even good. That was 20 attributes. And the idea about the classes, as I said, one idea was to detect alarm, so we need 2 classes. It was about 10 to 15% of the calls to be in such a class, alarm. It was, here we see 12%. And the further idea was to that class, that was regular class, not alarm class, to further divide into more classes to get more information. We would like to get more information, and we divide it into 3 more classes, small, normal, and bigger, to see if there's just a small number of the calls, so somebody from the staff within the control room can go to holidays. It is not necessary that is present here. Maybe in 2 days will be a little bit increased, so we would not allow somebody to go to the holidays. And in few days, 1-2 weeks, there will be alarm, because we see that all this data shows such an information. So from that data, we can, we will prepare the model, how we will prepare. So here is example of the November flooding 2014, how in ideal case we would translate the number of calls into the one of the classes, of 2 classes or 4 classes. So in total, it was made 125 models for the whole year period, quarters for Slovenia, Ljubljana, for 2 classes, 4 classes, and different methods from the artificial intelligence were used. Random forest, meta like ADA boost, support vector machines, naive Bayes. We decided to use classification, not regression, not time series, but classification because we would like to prepare the more general solution. And also very necessary steps within the artificial intelligence, normalization of the data, because the data or the input data calls were very imbalanced. The classes were imbalanced. We need to do balancing. And also sensitivity, 10-fold cross-validation, and at the end, it was prepared the model, and the accuracy was set as the cost metric to be used. And the main point, how to use the model. So from the 2013 till 2016, we have prepared the model and make the assumption and what are the results. And then we use also this model on the new data from the year 2018 and also make the evaluation. But in the future, such a model can be used in the on the data of this year, or in the final stage, if we have data for the future, like weather data, if we can get from the portals what will be tomorrow weather, what will be the river flows data for tomorrow or the next days, we can put into our system or into our model, and then we can, within the controller, we can see and predict, forecast what will be the number of the incoming calls. That's the final stage of this ecosystem. So here are the results. That was the random forest. That's decision tree model and meta model algorithm. And the best results was about more than 95% of the accuracy. And we have increased the accuracy also with the quarterly models. And that results was best for the Slovenia and two classes. It looks for the 4 classes, it was within the first time period, it was quite good results, but for the second, because of the bias, it was not so good, but this is the challenge for the future research. So that was the general framework that we have see or check how to prepare for the control rooms for different use cases with the forecasting of 112 calls. And we have see that open data are very good source, are really golden source. And in Slovenia, in our case, weather data and river flows data can be very good. And the random forest looks a very good, promising algorithm. So without any new algorithm. And also quarterly models improve accuracy. And conclusion, very good conclusion, what's about the data handling. Here is a lot of work about cleaning, manual work, and we see a lot of possibilities how to do more automatic way, how to even improve all this ecosystem with some further steps within the data handling. Okay, thanks. That's from my side. Okay, maybe just one. That was the part of 5G safety project. Also, it was co-funded by Slovenia and United European Union, also with the support of EENA. Thanks for EENA. And we have also prepared the prepared the patent in Slovenia for such cases, for the forecasting of incoming calls. No? Just this.
Perfect. Thank you very much. Any questions from the audience? I don't see much on the back. No. Okay, then we can move to the final. You have one? Oh, okay, go ahead.
Hi, yeah.
Sorry.
I just, in response to the question that I got, I saw that you had different activities, one of which was the data preparation.
Yes.
And I wonder, for the gentleman's benefit, if you could tell us about what proportion of time that took out of that initiative?
A lot of time, because it was nothing automatic, quite not automatic, but some data were present. For 112 number, it was on the internet, just download. for other data like weather data and river flows data, it was a little bit more difficult to get them. And then to prepare some data were missing. I need to interpolate some data because from some of the stations they were not missing data. So interpolate that data or to get from the more important stations. The main point, as I see, was very hard to automate all this work. So no JSON, HTTPS interfaces are happy to put into the product and to be quite automatic way, just manual work. So this could not be used in the real cases. So I think also for the history data, maybe for the existing data, it's a little bit better. But for the historical data, we don't have data, difficult to get all this data. So I think here it would be very good if we can, if the society could provide all this open data for such a purposes, for the benefit of the citizens of all the people here.
Thank you.
Nice, perfect. So now we're going to have Michael O'Donnell talking about how to use the digital twin for pre-incident planning.
Thank you, Alfonso, and thank you everyone for coming to see this presentation. I'm going to be talking about reality models for emergency response. First, a little bit about myself. My name is Mick O'Donnell. I'm a firefighter paramedic for 16 years in Dublin Fire Brigade. I've worked on fire engines, ambulances, control room, major emergency management, and now I've kind of morphed into a data person within Dublin Fire Brigade. So I head up data analytics for our Operation Intelligence Unit. So this is a proof of concept that we developed. I suppose we recognized that we needed to improve our pre-incident planning processes and move from a very analog, paper-based system to a more digital, connected system. In conjunction with, we have a very good smart cities program in Dublin, and we use those connections and forge some links with industry to look at what's available and what we can do with these technologies. So a little bit about Dublin Fire Brigade. You know, about a 150-year history as a fire authority, 100 years with an ambulance, 1.6 million population. So 2019 is the last year of reasonable, you know, reliable data, you know, in terms of no outliers there. And you know, we have 22 fire tenders spread across 14 stations, 12 ambulances, and about 1,000 people. This fire happened soon after the establishment of the fire authority. It's known as the Great Whiskey Fire. It was a distillery that exploded and burnt down. So the fire service did a great job at this incident, and no one was hurt in the inferno. But by all accounts, 6 to 10 people were harmed by the flaming shots of whiskey flowing down the street and trying to have a little bit of it. And it's uncertain whether there was firefighters in that counted in that number. So I suppose just to talk about pre-incident planning, it's what we do to kind of assemble information before we get to an incident. So high-risk sites, you know, high-impact sites. So, you know, helps us to manage situational awareness and basically should give us better outcomes in terms of life and property saved. And questions about how well do we manage the information we collect, how do we communicate it to our incident commanders, and how do we deploy it, and how do we use it throughout the organization. So we shouldn't just have it locked into a pre-incident planning database, we should use it across all strategic functions of the organization. This is kind of what we had. So again, kind of a directory-based structure with pre-fire plans. Do not rename this folder. So you can see how, you know, the resilience mightn't be great there. So we go through a district, then we click into the site location. And traditionally, we use PowerPoint slides to collect this information. You know, great advantages to it in that it's quite ubiquitous. You know, PowerPoint will run on virtually every machine, but the information is locked in there. There's no connectivity. Very difficult to update. You know, once you publish it, it's out of date. So, you know, the team in the OIU, came up with 3 phases in terms the collection of the information. So, ideally we want to use digital forms and collect, metadata, locational data, height data, so that we can plan ahead and use augmented reality in 10 years' time. So we're using information from our pre-incident planning process, from our post-incident reporting, and then most fire authorities, certainly in Ireland, we have a regulatory function, so we will issue certificates to buildings, so we should be pulling in that information, and then using open data, which is a very important part, and external data sources via data sharing agreements, etc. The management is very important, obviously, validating it, enriching it, joining it, and securing it, making sure only the people that should have access to it have access to it. Communication then, and this is, I suppose, what the focus of today's talk. So, we can use it in analytics, strategic, operational. We can use it as a tactical aid to give situational awareness. Using training and interoperability. So major incident exercises, we should be able to share this data. And on the incident ground then, we see 2 tiers of communication. One is the pre-arrival information, so the scene size up, where you get really frugal information that informs the incident commander before they get there. And then detailed information. So if the incident escalates into a major incident or protracted incident and things stabilize, that we can actually dig into the information and get detailed data about the risk site. So again, accessing the information, we don't have to go through a directory. We can use a map, click on a point of interest, and that'll open a link, which we, as it's loading, streaming from the web, the first thing that pops up is some really quick descriptive information about the site, telling us what we need to know, and including any information that we already have, our historic data. And you can see here, this is a reality model developed from drone photogrammetry. So we have pre-canned viewpoints where we see the main marshalling point. We see some of the main buildings. We can navigate our way through and see the places we need to know about. So in this model, we have a hydrogen plant, so quite a risky site, an air separation unit. And we can pull up points of interest about that and get information that we've loaded into the system. So one mnemonic that's quite common in the fire service for management of fires is cold was well. This is how we train our incident commanders. I think it originates in the FDNY. It's hard to get the exact attribution of who came up with this, but these are the things that we need to know before for an incident commander to get a good scene size up before they can start implementing their tactical plan. So, and as you can see here, we estimate that we can hit 70% of the information that we need for an incident commander pre-arrival with pre-incident planning, and then present it in a way that's very accessible, very usable. So construction is the first of these headings. So obviously the reality model will give us a very good information about the construction. If the incident commander would have been trained in building construction methodologies, etc., they're going to know that this is a reinforced concrete building with curtain walls, and it's 24 stories. So the reality model is very beneficial. Then we can link out, because it's a web-based technology, we can link out to, very, very useful ubiquitous services like Google Street View. So we can include a link to Google Street View that's driven by the location, and we can, get more detailed information than the actual reality model might be able to provide. And then looking towards the future, BIM models, I think it's probably definitely in Ireland about 5 years away before these will become useful in the emergency management space. But you can see here the richness of information that can be supplied by a BIM model. It's probably a bit too much information in its current state, but it can be tailored for our use purpose. Occupancy then is the next thing. So who is using this building and what is it being used for? Again, Street View is an asset there, be able to get it. Then if we have an organizational risk database that's stored in a data warehouse on the cloud, spatial data, we can link to that and drive a click-through action on the polygon that gives us information about that, summary information about those buildings. So this is information surrounding the detailed reality model, but we have all that available to us. The area, very important piece of information. The water demand for a fire, is typically driven by the area involved. So I think it's for 100 meters squared, you're looking at a 500 litre per minute branch to control that fire in a structure fire. So you can see here measuring the area, and we've about 228 meters squared. So if it wasn't a chemical factory, we'd be talking about 2 500 litre per minute supplies. The location of the fire, it'd be wrong of me to say that it isn't most important for the incident commander to make their 360 assessment of the scene. So visual is going to be important there. But what we can also do is, if we have our drone team on standby, we can stream to a fixed endpoint. We can include this web endpoint in the model, and then display that when we need to, and then we get access to that drone feed. It's in one place, easily accessed by the incident commander. So you've all seen drone feeds before. I'm not going to let it play out for the minute or two that it has. Water, again, really important. Like the area calculation, knowing where we can access the water, very, very important. So here we have going back to our reality model. We can include web mapping layers from our National Water Agency. Within this, turn off our street base map, turn on our water distribution layer, and we can see all the water networks within that map. Again, it's streamed from the web, one source of information. We don't need to take care of updating. It's done by the Irish Water. Again, there will be some sites that don't have mains hydrants on them, that have their own ring main. We can include those as points of interest within the model itself. So we get all that information bundled into one place. So appliances, we include we can include a telemetry feed. If it's a web native service, a browser-based service, we can pull in that via an API. Or we can use these reality models as a training tool. So we import a simple Collada model, which are widely available for free on the web, and we can do some scenario assessment for these. This is one of our major cathedrals in Dublin, so we're seeing aerial access and asset placement on that site. Street conditions, again, go back to Street View. It'll give an overview of what parking restrictions we might have. Is there lines from our light rail system? Is there power lines, etc.? Weather then, very important factor for wind-driven fires, especially in high-rise. Dublin is an increasingly high city, lots of tall buildings currently being planned. But you can see here, again, we're just including a location-driven link to a weather app, and we can see there the winds coming from the south at 16 kilometers an hour. I'm not going to go into detail on the rest of them. As you can see, we're taking care of exposures, so the surrounding buildings via our reality model, Street View, and the BIM model. The appliances, so what's available within the building? Is there a dry riser? Is there a water tank on site? Again, available via that. What life hazards are there? So visual assessment by the incident commander and our drone feed. What time implications are there? So again, this could be some Internet of Things stream that comes in, and then the height of the building measurement, or looking at the reality model. So I suppose just to say in summary, as a fire authority, having a connection to a smart cities is a great thing. Or it really enables interaction with industry on some of these innovative projects. Highly recommended for any first response agencies there to seek out your smart cities programs. using a central data warehouse that we can use to suck data into other applications is essential in my opinion. The presenting information in the context of its location and space, it's been said all the time in terms of mapping and 2D products, but we're entering a space where it's going to be in 3D. We'll have height information, and preparing for that, these 3D models is very important. Cloud-based systems by preference, allowing interfacing with third-party applications, even free ones, the ubiquitous ones. And then in terms of horizon scanning, building information models, standards aren't, the supply of models aren't at a standard yet within Ireland that we can kind of rely on them for consistency. But again, it's something we need to plan for. Internet of Things and APIs with our organizational systems, such as our dispatch system, would be all things we want to build into such a system. Thank you very much. That's it from me. I suppose there's my contact details. One of the projects we're also working on related to this is on a predictive model for building fire risk. So if you keep an eye on my LinkedIn, I update on that a bit, but it's kind of feeds into this space of predictive analytics. And it's another partnership project with one of our national centers for high-end computing. So yeah, thank you.
Thank you very much, Mick. Any questions from the audience? Yeah, there's someone. Yeah, the microphone is arriving.
Sorry. Oh, okay.
Thanks.
Thank you very much. Mick, my name's John Hall, Fire Chief for 35 years. Where we're moving with data provision to first responders is incredible and really powerful, but the limiting factor still seems to be the brain and the ability to assimilate that information of the incident commander. Are you backing up the sheer volume of data you're pushing at incident commanders with somebody that can interpret it for them and filter it for them, or is that assumed that within the existing command structures you've got somebody on the ground to actually do that? Information overload is the question, sorry.
Yes, it's a very, very valid point. I suppose the focus of this presentation was on that cold walls wealth implementation and just giving that pre-incident information. We've had feedback and workshops with our staff. It is, you have to learn this system to understand it, etc. Ideally, what I'd like to have is, a cold walls wealth in a context-driven. The location of the fire plus the location of the incident plus the nature of the incident dictates that fast, frugal, heuristic information that's delivered straight away to them. And then with links they can go to see the actual reality model or whatever they need to consume, whatever they have time for. I don't know if that answers your question.
Yeah, it kind of does. I'm linking it in with what we've all seen out the front door here, which is the mapping unit that Côte d'Ivoire, Sapeurs-Pompiers and whatever you're using now, where they're providing dedicated data units to first responders. And you kind of think if you've got somebody saying, Gov, have you noticed this? That's really helpful. And I kind of think that we're moving towards a position where you almost need that intelligent interpretation of the vast volume of data that's being fed. Because although the pre-information is highly valuable, also the dynamic information is highly valuable as well. No, it's good work, thank you.
Yeah, I suppose just to follow up, it's a very difficult thing to solve. You have a balance between trying to supply as much information as the incident commander needs without overwhelming them or distracting them from what they want to do. I suppose what I would always fall back on is the fact that, sorry, I've lost my train of thought altogether. I'll follow up with you after.
Perfect, thanks. Any other question from the audience? Nope. I do have a question. Oh, yes?
Yes,
It's very hard to see. Perfect, go ahead.
Hi, my name is Erica. I'm from the Netherlands, and I got a question in how do you manage all your data? I see open source data, but I also see data that you're using from your own organization. How do you manage that?
Thanks. Yeah, and actually, it's what I was going to say. You know, what you also want to do is create a monster that requires 10 staff to manage. You know, and most fire services, they're focused on fighting fires, not managing data. I think models like this, where you do your data management once and put it into your data warehouse, is the key, and you push it out then to other services. How do we manage it? The predictive analytics project that we're doing is actually really answering a lot of those questions, because it's, again, data quality is showing a real issue. And I think one thing a comment I'd make on that is data governance is a huge untapped, data governance within fire services, all types of organizations. I think it's going to be one of the biggest growth industries, because predictive analytics needs good data. If you don't have good data, you're going to spend all your time, 90% of your time, correcting the data before it goes in. But as I said, how are we managing the data? I wanted to make this as lightweight as possible in terms of the resources it took. So we're using our drone teams to in their training to take these models, bring it in. We have that model. We will try and get BIM models from industry or from the certifiers when they're sending in certificate information. So all things like that, trying to build those information feeds through other processes is the most important thing.
Thank you.
Okay, a quick last question. Very quick. Microphone? Yes. Oh, yes.
Thank you. My name is Maarja-Liisa. I'm from Estonia. And my question is about linking your prevision of these houses with emergency response centers programs. Do you need anything special to link these solutions that you have, or is it just based on address? That you get an address from us and then it's going to show you everything?
Thanks. Yeah, I mean, this is a proof of concept. So as I said, it would be driven by, you have a map with all your incident locations on it. And generally, your incident commander will be from the district that the emergency is in, and they'll know the high-risk sites, which are the models we have. So they should be able to find that on the map. But yeah, ideally, you'd have it integrated with your CAD system, and it can drive the link going through to the terminal. Does that answer your question?
Okay, so while developing a CAD system, this needs to be in mind also.
Yeah.
Already.
I think so, but I guess I would kind of leverage the fact that it's web-based. Each of these plans is available via a URL. So, it's a simple string that can be sent out to a tablet and clicked on. And if the user can authenticate, they can get into that model.
Thank you.
Yeah.
Perfect. Thank you very much. Thank you also all of you for staying here with us. Just to follow up on the next sessions, there is a networking cocktail now at the exhibitor area. And there's as well another session on the research corner on track 3. And most importantly, at 6 o'clock, we have the 112 awards in the main room. So don't miss that out. Thank you very much.